All right, so let's dive into some research that could completely change how we think about AI. Imagine being able to guarantee your AI gets the answer right. Like even on those super complex problems, the ones that make you sweat a little, that's what this Alibaba Group research is hinting at. And it's definitely got the AI community buzzing. They call it a simple and provable scaling law for the test time compute of large language models. It's a mouthful. We'll unpack it together, don't worry.
Yeah, what's fascinating is instead of just trying to build a bigger LLM, they've found a way to potentially squeeze way more accuracy out of the ones we already have.
That's what caught my eye too, it's like finding a hidden turbocharger. For our existing AI, I know this paper gets pretty technical, but
Yeah.
you always manage to make this stuff make sense. So what is the core problem they're tackling?
Well, LLMs are powerful, but they can be unpredictable. Sometimes they get things wrong, which is a major issue if you're relying on them for something critical.
Yeah, right. It's that whole hallucination problem. That makes people hesitant to fully trust LLMs for important tasks.
Exactly, and this research offers a two-stage solution. That's surprisingly elegant. First, the LLM generates multiple potential solutions to a problem. Think of it like having a team of AI assistants, all brainstorming different approaches.
Okay, so it's not about the LLM being right on the first try, but rather generating a diverse set of options.
You got it. Then comes stage two, the knockout round. The LLM essentially judges its own work, comparing pairs of solutions and picking the winner, based on which one seems more likely to be correct. This happens in rounds, like a tournament, until only the champion solution remains.
So it's like they're using the LLM's own abilities to refine the results. But where does that provable scaling law come in? I kept seeing that phrase pop up in the paper.
That's the heart of this research. It's where things get really exciting. They've actually proven mathematically, under certain conditions, pumping more computing power into this algorithm dramatically increases your odds of getting the right answer. The probability of failure actually drops exponentially.
Oh, wow. So we're talking about increasing the number of solutions generated in the first stage
Yeah.
and the comparisons made in the second stage.
Precisely. And the beauty of this approach is its minimalism. You don't need any fancy external tools. It's all about cleverly utilizing the LLM itself.
I see. So what are those certain conditions you mentioned that make this whole thing work?
Well, there are two key assumptions. First, the LLM needs at least a tiny chance of stumbling upon the correct solution. During that initial brainstorming phase, it doesn't have to be perfect right away, just capable of generating the right answer somewhere in the mix.
Yeah, that makes sense. So it's about potential rather than immediate perfection, was the second assumption.
The LLM also needs to be better at judging between solutions than if it were just flipping a coin. It needs some level of actual discernment.
Okay, so it needs to be able to recognize a good answer when it sees one. But how did they actually test this out in practice? Did this theoretical scaling law hold up in the real world?
They used a benchmark called MMLU Pro. It's notoriously tough. It tests LLMs across a huge range of subjects, from STEM fields like math and engineering to humanities subjects like history and psychology.
So they really put this algorithm through the ringer. And what did they find?
The results are pretty compelling. They saw a clear correlation between increasing the compute power and increased accuracy. But here's where things get even more interesting. The algorithm's success varied, depending on the type of question. For tasks that involved a lot of logical reasoning, like those tricky math problems, the gains in accuracy were significant.
So it's like the LLM is actually learning and refining its reasoning process through those comparisons in stage two.
That's a great observation. For questions that relied more on just knowing a specific fact, the improvement was less dramatic.
Yeah, that makes sense. If the LLM simply doesn't have the knowledge stored from its training data, no amount of clever comparison is going to magically create that knowledge.
Right. But the researchers did some fascinating visualizations. To explore this further, they plotted something called PGen, which is the probability of generating a correct solution in the first stage.
So PGen is basically how likely the LLM is to hit on the right answer right out of the gate.
Exactly. They plotted that against pcomp, which represents the probability of making a correct comparison in stage two.
Okay, I'm picturing a graph with PGen on one axis and pcomp on the other. What did the graph reveal?
What's fascinating is that even for questions where PGen was low, meaning the LLM wasn't getting many right answers initially, as long as pcomp was high enough,
Meaning it was good at judging between solutions.
the algorithm could still find the correct answer through those knockout rounds.
That's really counterintuitive. So even if most of the LLM's initial ideas were off base, it could still course correct through that comparison process, as long as they had a good sense of what a better solution looked like.
Exactly. It suggests that even with existing LLMs, there is a hidden potential for much higher reliability than we previously thought. It's just a matter of tapping into it.
This is incredibly exciting. But before we get too carried away, what are some of the limitations they highlight in the paper? What could hold this algorithm back from being the ultimate solution?
One thing they point out is this approach works best when a complex task can be broken down into smaller, more manageable subproblems. This is where the idea of AI agents comes in.
AI agents. You've mentioned that a couple of times now. I'm
Yeah.
definitely sensing a future deep dive on that topic. But
Yeah.
for now, what other limitations do they discuss?
Well, they acknowledge that this might not be the most optimal algorithm possible. There might be even more efficient ways to achieve the same or better reliability. That's something researchers are still exploring.
So there's always room for improvement.
Yeah.
But even with these limitations, this research seems to be pushing the boundaries
Yeah.
of what we thought was possible with LLMs.
Absolutely. I think one of the biggest takeaways is that we might be underestimating the power of
Right.
the LLMs we already have. What if, instead of solely focusing on building bigger models, we spent more time designing smarter algorithms? That can truly unleash their capabilities.
That's a profound thought. It's not just about brute computational force. It's about elegance and strategy in how we utilize that force. This research really opens up a whole new way of thinking about the future of AI. But we've only scratched the surface of this paper. There's so much more to unpack, especially when we start thinking about the broader implications of this research.
Indeed, there is this two-stage approach. And the idea of a provable scaling law could have a significant impact on how we develop and deploy LLMs in the future.
Well, let's keep diving. One thing that really struck me was how flexible this approach is. It's
Yeah.
something they call an anytime algorithm. What does that mean exactly?
An anytime algorithm can adapt to different compute budgets. You don't have to decide up front how much computing power you're going to throw at it.
So you could start small.
Yeah.
And scale up if needed. Like, let's say you're in a hurry and you only have time to generate a few initial solutions.
Exactly. The algorithm does its thing. You get an answer, but then let's say you suddenly have more time or access to a more powerful computer. You can just generate more solutions, have them compete against the previous winners, and the algorithm will refine the answer further.
So it's like you're constantly improving the solution as you go.
And the really cool part is, mathematically, it's the same as if you had run the algorithm with all those solutions from the very beginning. It's adaptable and efficient.
This is starting to sound like it could be a game changer in how we think about LLM accuracy. Is there anything else about this flexibility that's worth highlighting?
There's one more fascinating detail. Remember, Kay, the number of times each pair of solutions gets compared in the knockout stage.
Yeah, we talked about that. More comparisons should theoretically lead to a more reliable answer, right?
That's the initial thought. But the researchers found something interesting. When they looked at it from another angle, they suggest that even if you keep K low, meaning you only do one quick comparison between each pair.
So a very minimalist approach
Right.
to the judging process.
Yes. But as you increase N, the number of candidate solutions generated in the first stage, the overall accuracy still seems to go up.
Wow. So even with very simple comparisons, the key to higher accuracy might be in generating a wider array of initial solutions.
That's what their analysis suggests. Though they do acknowledge more research is needed to confirm this.
It's like saying, let 1,000 flowers bloom.
Yeah.
The more diverse your initial ideas, the better your final result will be, even with a very simple selection process. This whole thing is really making me rethink how we optimize LLMs.
It's a paradigm shift. Maybe it's not always about adding complexity, but about understanding the core strengths of LLMs and using them strategically.
Which brings us back to your earlier point. This research might be showing us that existing LLMs are far more capable than we give them credit for.
I truly believe that's the case. Now, where this gets really interesting is when we start thinking about potential real-world applications. Where could this actually make a difference?
Okay, let's talk practical implications. What are some areas where this kind of reliability boost?
Could be a game changer. The most obvious applications are fields, where even a small mistake could have serious consequences. Healthcare, finance, legal decisions, things like that.
In those cases, you'd absolutely be willing to invest more compute power to ensure the LLM is giving you the most reliable answer possible.
Precisely. But I think this research also has huge implications for for the development of AI agents.
You're bringing up AI agents again. Now I really need to know more. How does this algorithm tie into the agent world?
Well, one of the biggest challenges with AI agents is breaking down big, complex goals into smaller, more manageable tasks. Remember how the researcher said this algorithm works best when tasks are decomposable?
Yeah, I'm starting to see the connection now.
Imagine an AI agent that's helping you plan a vacation. That's a lot of moving parts to handle.
Flights, hotels, activities, transportation. Yeah, it can get pretty overwhelming to think about all those details.
Exactly. But what if the agent used this two-stage approach to break that big goal, planning the trip, into a series of smaller subproblems?
Like, find the cheapest flight, book a hotel near the Coliseum, suggest activities based on my interests, that kind of thing.
Exactly. And by applying this algorithm to each of those subtasks, the agent increases its chances of getting each step right.
Leading to a much more reliable overall outcome. No more ending up in the wrong city or the hotel miles from anything you want to see.
And here's where the anytime aspect comes in. If the agent hits a snag with one of those subproblems, and it's not confident in the solution it's come up with, it can simply loop back, generate more candidate solutions, and keep refining the answer until it reaches a higher level of certainty.
It's like having a super organized personal assistant who's constantly double-checking their work to make sure everything is perfect.
That's a great analogy. It hints at the potential for more robust and dependable AI systems, all thanks to this relatively simple algorithm.
I think we might need to bump AI agents
Yeah.
to the top of our deep dive list. This is way too fascinating to ignore. But for now, I think we've covered a lot of ground with this Alibaba research.
We've only just begun to explore the implications, but I agree. It's time to start wrapping things up. Any closing thoughts before we officially end this deep dive?
Yeah, that is a fantastic question. It really makes you think about where the real innovation in AI is going to come from. It's like we've been so focused on building bigger hammers
Yeah.
that we've totally forgotten about the art of actually wielding the hammer.
Exactly. And that's what makes this Alibaba research so compelling. It's a reminder that sometimes the most groundbreaking advances come from shifting our perspective, from finding elegant solutions that leverage existing tools in new and unexpected ways.
It's like we've stumbled onto a whole new design philosophy for AI. Instead of just scaling up, what if we focused on scaling smart?
I love that. Scaling smart, it perfectly captures the essence of what this research represents. It's about recognizing that true progress in AI isn't solely about computational power, but about ingenuity, creativity, and a deep understanding of the tools at our disposal.
This paper has really opened my eyes to the possibilities. And it makes me wonder, what other hidden talents are lurking within the LLMs we already have? What other breakthroughs are waiting to be discovered if we just approach the problem from a different angle?
That's the beauty of research. It's about pushing the boundaries of knowledge, exploring uncharted territories, and constantly questioning our assumptions. And this particular paper, with its deceptively simple title, A Simple and Provable Scaling Law, has certainly sparked a wave of excitement, a new avenue of exploration.
It's a powerful reminder that the field of AI is still in its early stages, full of untapped potential, just waiting for those aha moments that can redefine what's possible.
I couldn't have said it better myself. It's an incredibly exciting time to be working in this field, and I can't wait to see what the future holds.
Well, on that note of optimistic anticipation,
Yeah.
I think we've reached the end of our deep dive. As always, a huge thank you to you for sharing your expertise and guiding us through this fascinating research.
The pleasure was all mine. I always enjoy these deep dives, and I hope our listeners found it as thought-provoking as we did.
And to everyone listening out there, thank you for joining us on this journey of discovery. We hope this episode sparked your curiosity about the ever-evolving world of AI. Until next time, keep exploring, keep questioning, and keep those minds engaged.